Okay, so we should be going. All right, so on your notes, hopefully everybody's got their notes out. What you should write is something. So instead of writing all this stuff down, there's one main point. Okay, so when using interval notation, okay, so one thing real quick, you guys should be confused, or you should be used to using inequalities. So real quick, let me just graph something. An inequality would look something like this. And you'd either have an open dot, where it's open because it's strictly greater than or strictly less than, or you would have a closed dot when it has a greater than or equal to, or less than or equal to. So when it has that equal to sign, it's a closed dot. When it doesn't have the equal to sign, it's an open dot. And then you're going to have an arrow pointing in a direction, okay? And we'll get to some more of those examples in a second. Now, here's the notes and what they're saying. When we write interval notation, which is something that you guys have not done, when we write interval notation, I'll just write it for this. You're going to read from the left to the right. So this arrow, an arrow means it goes on forever. So how far would it actually go? What do you guys think? What do you think? Forever. What's a number that describes forever? Infinity. So this actually is going to negative infinity, okay? So my interval notation would look like, I'm just going to write it here, negative infinity, and then it would go all the way from the left to the right, and it would stop at what spot?
0.
Well, no, it goes past 0.
2.
It stops at 2, okay? And it stops at 2, and now here's the thing. Does it hit 2? Is it a solid dot? It's a solid dot, and here's the notes. When it's a solid dot, use a bracket. Pretty much for anything else, not pretty much, for anything else other than a solid dot, you're going to use a parentheses on your interval notation, okay? So that's what you would want to write down. When using interval notation, use a bracket for a solid dot. That's what you want to write down for your notes. And then you could write, for anything else, use a parenthesis. Okay? And now what I'm going to do is I'm going to give you guys about 30 seconds to write that. And then, because we've only got about 10 minutes, I'm going to work through maybe 3 problems. Okay? Yeah, that's fine. Okay, so, and I realize you guys might not have been able to write all that down, but again, I'm going to post this video so you can actually see it online. So let's go through 3 problems real quick. So I'm going to start with an easy one, and then maybe I'll do a medium one, and then I'll do a more difficult one. So the solving aspect, like I said, you need to learn to solve. You solve these almost exactly like you solve something like an equation. Okay? So right here, if I'm solving it, the first thing I'm going to do is distribute my parentheses. Right? So I'm going to have 4 times x, 4 times 3, so I have 4x plus 12 is greater than negative 24. All right, then I'm going to, what's the next thing I'm going to do, Tomoso? What's the next thing?
Alright, so you add 12 to 24.
I need to move my 12 over there so I can isolate my variables, right? So I'm going to subtract 12 from both sides. So I'm going to have 4x is greater than negative 36. And then the last thing I'm going to do is what?
Divided by 4.
Divided by 4. So I'm going to divide by 4 on each side. So we're going to have x is greater than negative 9. Okay, so there's the solving aspect. I'm hoping everybody can do that. Now, here's the graphing aspect. I'm going to graph it over here. So, first of all, there's not even 9 hashes here. So there's no way I can count to negative 9. So the point is, you need to have a 0 somewhere and think to yourself, okay, is negative 9 this way or is it this way? So obviously that way. Okay, so negative 9 is a smaller number. So you don't have to count 9 spaces over here. Just put a negative 9 somewhere. Let's put it here. Negative 9. All right, now above negative 9, you're going to have some kind of dot. Is it going to be a filled dot or an open dot? It's going to be an open dot because if there was an equals on there, then it would be a closed dot. Okay? But it's not. So it's an open dot, and it's saying that x is bigger than negative 9. So where are all the bigger numbers? Are they to the right or are they to the left? To the right. So that's how you would graph it. Okay? And I'm going to go through 3 of these examples, all right? So that's how you would graph it. Now let me show you real quick the interval notation. Interval notation, reading from left to right, what's the first number that I see? Going left to right, what's the first number I see over here?
-9.
-9. So do I hit -9? Is it a closed dot?
No.
No, so I'm going to use a parentheses, -9, and it goes all the way to, where does it stop?
0.
It doesn't stop. It keeps going, so it goes to infinity, positive infinity. And that's what my interval notation would look like. Okay? So let me do 2 more. Let's see. This will be a good one to do. Okay, I'm going to go ahead and do number 4. So I'm going to erase this just based on time. So number 4. Number 4, let's see if I can zoom in. That'll make it better. Okay. Can you see that? All right?
Yes.
Okay, good. So we're going to distribute, again, first thing, distribute. So I have -8 times x, -8x. -8 times -1 is +8. Minus x is less than or equal to -28. I'm going to combine my like terms. Right, Hadab? So the 2 x's, I'm going to put these things together. So I have -8x minus x is -9 x's. So those are combined now. I have a +8 less than or equal to -28. I'm going to now try to get my x's by themselves, right? So I'm going to get rid of everything on this side. So I'm going to do -8 on each side. So I'm going to cancel these. -9x less than or equal to -36. Now here's a question. Here's something that's going to make this different than solving an equation. Finally, we're at a spot where it's a little bit different. What's going to happen when I divide by a negative? I haven't taught you guys this, but I know you've been taught it in the past. What happens when you divide an inequality by a negative? Does anybody remember? Do you remember, Sebastian? Well, that's not the only thing we're going for. So I need to divide by -9. So these cancel, great. So I'm going to have x is less than or equal to, oh, sorry, let me get rid of this. I'm going to have x and then -36 divided by -9 is going to be +4. Say that again.
You have to switch the sign.
The sign switches when you divide by a negative. Do you guys remember this?
Yeah, I remember it.
So if you've been taught it in the past, you should know if you divide by a negative, the sign changes directions. So you're negating the sign. All right, that's what happens. So let me go ahead and graph this real quick. So there's our answer. So I'm going to come over here. I'm going to graph it. So I'm going to put a 0, let's say here. And then I actually can fit 4 on here. So 1, 2, 3, 4 is going to be right there. So I'll go ahead and fit 4 on here. It doesn't matter. You can put 4 here. You can put 4 anywhere you want. That's fine. The point is 4 is over here somewhere. Now, as far as the circle is concerned, you see the equals on the bottom? That means it's going to be a closed dot, right? So it's filled in. And it's saying x, it's eating the bigger thing, right? So x is bigger than 4. So where are all the bigger numbers at? Bigger numbers are to the left or to the right?
Left.
They're to the right. Bigger numbers are over here. So like this is where 5, 6, all the way to infinity.
Mister, my old teacher would tell us the direction of it. You just go like that.
I'm glad you said that. So let me write interval notation real quick, and then I want to talk about that. And that'll be the last example on this video. So I said I was going to do 3. I'm going to stop here. So interval notation, reading left to right. What's the first number I get to?
0. No, 4.
4. Okay. So it's going to go from 4, and it's a closed dot. So this is where I use a bracket. Closed dot all the way to, where does it stop? Infinity. Okay, good. Good, guys. Okay, so the question she said, it wasn't a question. She said her old teacher said, when you have this inequality, it actually, if you can imagine it, it makes an arrow. Oops, that's not very accurate. It makes an arrow pointing the direction that the inequality should go. So if you see how this is pointing that way, she's saying that the inequality makes an arrow pointing the way that it should go. I want you to be careful with memorizing things, okay? Because look, let me explain, and I'm glad you asked that on this video. This is saying x is bigger than 4, right? Bigger than or equal to 4. So I'm not saying greater than or equal to. It's the concept, the logic is that x is bigger than or equal to 4, right? So if I change it and I do this, what's the concept here? X is still bigger than or equal to 4, right? So this is the same thing, but which way is the arrow pointing now? To the left, okay? So I would be very careful memorizing things.
Yeah, but you always said you have to put the variable first.
Do you always have to put the variable first?
No.
No, you don't always have to put the variable first. But if you do put the variable first, that trick works.
Yeah.
If the variable is not first, right, and you find it on the right side, then that trick doesn't work. So be careful, guys, memorizing too much stuff. What you really want to do is just make sense. What is it saying? X is bigger than 4. So where are all the numbers that are bigger than 4? Well, here's 4, and everything that way, right? That's the logic. Okay, can you go ahead and pause that?